Hello SpecFlow friends. Today I'm very excited because I would like to show you something that you have probably never seen yet. Working with SpecFlow without code behind files. Executing SpecFlow scenarios without code generation. I will show you this with the normal .NET framework, but at the end of the demo I will show you something which is related to the .NET Core support. I have prepared everything, so let's get started. I will use the usual calculator example to demonstrate this improvement. This particular example has two feature files. One has a single scenario and the other is a little bit more complex because it has a scenario with a data table in it and also a scenario outline with 3 examples. As this is a standard SpecFlow project, you can see that for all feature files we have a generated so-called code behind file, which is basically containing the test class and the test methods that are finally picked up by the test runner, in my case the Test Explorer window, and this is how the tests are actually executed. Working with the code behind files is not really convenient because they are holding some redundant information. So for example, if I change something in my scenario, let's say that I'm just changing the tag name, that then not only the feature file is changed, but also the code behind file. If you are working with a team, so multiple people are modifying the feature files, and so the code behind files, this can cause some nasty merging issues, and sometimes it's hard to resolve the conflicts. So we generally don't really like these code behind files, but unfortunately until now, there was no real option to get rid of them. What I would like to show you now is a new SpecFlow plugin, which you can use to get rid of the code behind files. The plugin itself is also hosted on GitHub, and eventually this will be probably part of SpecFlow itself, but since this is currently in a kind of beta stage now, it's easier to work with it as a standalone plugin. The plugin itself is compiled and uploaded to NuGet, so basically we will be able to use it as a NuGet package. So let's see how this works. Using this plugin is extremely simple. The only thing that I have to do is just to go to the Manage NuGet Packages and search for the package name. Once you find it, we just need to click on install and install the package. From the main name of the package, you probably guessed that actually this package is not only for SpecFlow, but this is really working with SpecFlow if it's configured with xUnit. If your project is not configured with xUnit, this plugin will not work directly for you. However, still in this case you can consider to switch SpecFlow over to using xUnit, and then you will be able to use the plugin. At the end of the demo, I will show you how this can be done without making big changes in your code base. Our project was anyway using xUnit, so this is just working fine. Once the NuGet package is installed, you have to do a few steps to be able to get this working. First of all, we would like to really get rid of the code behind files that you can do by just selecting the feature file, and in the properties window where you see this custom tool SpecFlow single file generator, you just need to remove this single file generator setting. As I'm doing that, the code behind file is immediately gone, so I just need to do it for the other feature file. And the other thing that I have to do is that I have to make sure that these feature files are actually copied to the output directory. The plugin currently works in a way that it runs all the feature files which are next to the compiled assembly or maybe in subfolders. So basically, to be able to run these feature files and run the scenarios within these feature files, I just need to make sure that they are copied to the output directory. Maybe in a later version of the plugin, the actual position or location of the feature files can be better configured, so you don't need to make this additional step. But right now, this is how it works. So I just need to set it to copy if newer. Once I'm just recompiling the project, the magic happens. As you can see, the Test Explorer window has been refreshed, and you see the scenarios that I have in this project, and it's even nicer because you also see the nice labeling for the scenario outline as well. And yeah, let's just run it. And this is it. We have a SpecFlow project, no code behind files, and still we can run the tests and enjoy the results. Of course, we can also make an error, so just make this scenario somewhat failing. recompile the project and run all the scenarios. And as you can see, now I have one failing scenario with the expected error message. So basically it works as you would expect. So as you have seen, it's very easy to use this project, and it's very easy to get rid of the code behind files. The steps are very simple. You just need to install the plugin from NuGet. You have to disable the code behind file generation just by removing this SpecFlow single file generator entry, and you just somehow make sure that the feature files are copied to the target location. At least this is how it works now. Since the plugin is in the beta stage, make sure you also check out the limitations that you can see on the GitHub page. As I have mentioned, this plugin works if you are using xUnit for your SpecFlow project. So as I promised, let's see what you can do if your project is not using xUnit, but for example NUnit. For that, I have prepared an NUnit version of the same project. So this is basically having the same feature files, but SpecFlow is configured to use NUnit. What this means basically are two things. One is that in the code behind files, in the generated code, we are using the different NUnit attributes. And also in your step definition files, especially in the then steps, you are using assertions to perform the validations in the then steps using the assertion library, which is packaged together with the unit testing framework. So this assert class is actually coming from the NUnit library. And you can imagine in a real project, you have hundreds of then steps and probably a lot of assertions in your code base. Switching over to xUnit fully would be probably quite much work because you would need to change all these assertions. However, actually to be able to just run the tests with xUnit, you don't necessarily have to change the assertions. Assertions are somehow packaged together with the unit testing frameworks, but basically they are just methods that are throwing exceptions. You can run your tests with xUnit, but still using the NUnit assertions. This is what I would like to show you now. So as you have seen, so this is an NUnit project, and I will not remove the NUnit dependency because I don't want to change my assertions. What I would like to do now, I'm just installing this plugin. And actually installing the plugin will also install xUnit to our project. So let's do that. Okay, now I'm doing the same preparation steps as before. So just selecting the feature files, remove the custom tool, and change the copying. Okay, and the only thing that I need to do, I need to just change the unit test provider to xUnit in the config file. It asks for regenerating the files, but since I don't have any file anymore, this is not so important. So I'm just recompiling my application, and as you can see, I still have the same tests and I can run them again. Right now this project is configured in a way that one of the scenarios are failing. So one of the scenarios are actually triggering that assertion that is still using the NUnit assertion, but it's still working, as you can see. So you can still see the right assertion. It was expecting 24 but got 42 as a result. So basically the only thing that I needed to change is adding the xUnit dependencies and changing the SpecFlow configuration in the app config file. Finally, let's see something related to .NET Core. SpecFlow doesn't have a proper .NET Core support yet, and one of the reasons for that was that the code generation that we have used for generating the code behind files were basically using an infrastructure that was not available in .NET Core. But since xUnit is portable and all the infrastructure that this plugin is using for eliminating the need for the code behind file is also portable, actually this opens up the opportunity to finally provide the .NET Core support. What you can see here now is not part of the released xUnitAdapter plugin, but just a proof of concept that I wanted to show you here. So basically what you have here is a simple .NET Core project. You can see that it's .NET Core from the references, and you can also see that right now I have switched over to Visual Studio 2017, and it also has 3 feature files in there. The SpecFlow Visual Studio extension is not even installed, so I don't see any syntax coloring whatsoever. I have a simple step definition file with a couple of step definitions, and that's it. Basically, this is a simple .NET Core test project. I have already configured this project with this proof of concept version of the plugin and the proof of concept version of the SpecFlow.NET Core support. So what you can see as a result, that the scenarios that we have in the feature files are all listed in the Test Explorer window. Unfortunately, I'm not yet able to run these tests from the Test Explorer window. However, running the same test from the command line is working already. So let me just show you that. So I have switched over to the developer command prompt and I'm standing in the folder of this test project, and I'm gonna run the test now with the related xUnit tool support. .NET xUnit. And what you can see is that it discovered all the 10 tests. Actually, some of these tests are failing on purpose, so having 3 failed tests is the expected result in this case. And as you can see, it's able to run our scenarios and able to show error messages and whatever result you would expect from a SpecFlow test execution. So this was the good news for today. We have a new plugin which you can use to get rid of the code behind file, and this plugin can also help us to finally get to the proper .NET Core support for SpecFlow, what you have just seen in this proof of concept. For further information, please check out the GitHub page, and you can also read my related blog post. Have a nice day.